All right, so let's talk a little bit about representing linear functions, graphing by making a table. So there's lots of different ways we can graph lines. One of the first ways we usually talk about in algebra classes is by making a table. So first of all, let's talk about what a linear equation is. A linear equation is an equation in which the variables appear in separate terms and neither variable contains an exponent other than 1. If you see an equation that has an exponent other than 1, it's definitely not going to be a linear equation. X and y also can't be multiplied by each other. So what does a linear equation look like when we graph it? Well, it looks like a line, which is kind of what it says in the name. Some examples of linear equations are y equals negative 2x, 3x plus 2y equals negative 4. X and y are separate terms. Even though they're being added, they're not squished together and being multiplied, and no exponents other than 1. Y equals negative a third x. We can also have some of those fractions and things in there. And then y equals 8 is a horizontal line. There's no x in the equation, but it will happen to be a horizontal line going left to right. And x equals negative 2, there's no y in that equation. That will actually be a vertical line. So let's take a look at our first example. And it asks us to find the 4 solutions of y, or find 4 solutions, not the 4 solutions. We actually have an infinite number of solutions, but we need to find 4 solutions of y equals 2x minus 1. You're going to notice for these that I always just use negative 1, 0, 1, and 2. Well, I shouldn't say always, but most times do. Sometimes I'll stick with all positives. I like to throw a negative in there. And the first thing I'm going to do is I'm going to replace x with negative 1. And again, I can choose any variables for x that I want. Keep in mind that you have to graph them. Like, I always have some smart aleck who's like, hey, I'll just choose 1 million. Well, you got to graph it. So choose numbers that are kind of small and easy for you to graph. So to figure out what y is, I showed my work all the way off to the right here. So I replace x with negative 1. 2 times negative 1 is negative 2, and negative 2 minus 1 gets us negative 3. So the ordered pair is negative 1, negative 3. Replace x with 0. So I'm going to do 2 times 0 minus 1. That's 0 minus 1, which is negative 1. So the ordered pair is 0, negative 1. Now, often we don't show this work section of the table, but we do often show either the XY table. Sometimes we put the ordered pairs off to the side too, but at the very minimum, you'd want to show the X column and the Y column here. Now let's replace X with 1, so we'll do 2 times 1, which is 2. 2 minus 1 gets us 1. So the ordered pair 1 comma 1 will be on this line. And then finally, we replace X with 2. 2 times 2 is 4, 4 minus 1 is 3, so the ordered pair is 2 comma 3. Now, on the second page of these notes, you're going to see number 6, which is the same equation, we just need to graph it. So the first thing we are going to do in class is make the tables, but then we're actually going to graph those. So I'm going to do that right here. This is on the next page of the notes. So I'm going to graph these 4 ordered pairs, and it should, fingers crossed, look like a line. So negative 1, negative 3 is going to be right about here. We'll go and graph that point. The next point is 0, negative 1. That's going to be right here. 1 comma 1, that is going to be right here. And then finally we have 2 comma 3, which is going to be right here. And we can see that they do indeed form a line, which is exactly what we want. So we're going to go ahead and connect these. I'll make sure to put arrows on both ends because it really goes on infinitely. So any points that are on this line will satisfy that equation. So the 4 points I have are some of the points, but they're not the only points. But I do like to put arrows on both ends because, again, I have other solutions which are points on this line that aren't necessarily graphed here, including some decimals and things like that. But again, we kept our fingers crossed that it forms a line. It does indeed form a line. That's exactly what we want. So let's go ahead and take a look at number 2. We start off with some pretty easy problems. This one's actually easier than the last one. So I chose my x-coordinates to be negative 1, 0, 1, and 2. So let's start with negative 1. We replace x with negative 1. Negative 1 plus 5 is 4. So negative 1 comma 4 should be a point on the line. Replace x with 0, 0 plus 5, or sorry, yeah, replace x with 0, goodness. 0 plus 5 is 5, so we get y equals 5. Our ordered pair will be 0 comma 5. This is what happens when it gets closer to summer. Even as teachers get distracted. Next, we're going to replace x with 1. 1 plus 5 is 6, so our ordered pair will be 1 comma 6. And then replace x with 2, so we have 2 plus 5, y is 7. So that ordered pair is 2 comma 7. On the second page of these notes or on the back of that page will be your graph. So let's go ahead and graph -1, 4. These are all going to be like really close together. We've got 0, 5, which is going to be right here. 1, 6, which is going to be right here. And 2, 7, which will be right here. They do indeed form a line, basically going up 1, right 1, and that's because this line has what we call a slope of 1. Slope is the steepness of the line. It also, if we look at the pattern that's happening with these numbers, go ahead and just make that a double-sided arrow there. Oh, let's see, just kidding. I got this. We look at the pattern in the numbers here, we can see that as our x's are increasing by 1s, our y's are also increasing by 1s, and that's kind of how we get that slope or steepness of 1. If we go back to question number 1, as our x's were increasing by 1s, our y's are actually increasing by 2. You might notice that this line is a little bit steeper, and that's because it has a slope of 2. You might also start to notice that that number in front of x happens to be the slope or steepness of the line. Well, that's something you'll explore more in algebra for sure. All right, let's take a look at number 3. So we have y equals -3x plus 4. We're going to replace x with -1 first, and we'll do -3 times -1 to get 3, add on 4 to get 7. So -1, 7 will be an ordered pair. Replace x with 0. Now, you should always use 0 if you can, because that's usually the easiest one to calculate. We'll do -3 times 0 to get 0. 0 plus 4 is 4. So 0, 4 will be on this line. We now have x equals 1. So -3 times 1 is -3. -3 plus 4 is going to get us 1. And that ordered pair will be 1, 1. And finally, replace x with 2. We'll do -3 times 2 to get -6. -6 plus 4 is -2. You might notice that as the x's are increasing by 1, the y's are actually decreasing by 3. So this one's going to have a slope of -3. And again, if you're like, I don't really know what slope is, don't worry. It's a later lesson. It's something you'll explore more in algebra. But it also happens to be the number in front of x, and you're going to notice something different about this line compared to the previous two lines. So let's go ahead and graph those points. And we'll start with -1, 7, which should be right up here. We also have 0, 4, which should be right here. We have 1, 1, which should be here. And 2, -2, which should be here. So they do indeed form a straight line, which is exactly what you want. But what do you notice about this line compared to the previous two lines? You might notice something about it. If you're noticing or thinking, wait, this one goes down instead of up, it does. The other ones go in an upwards direction from left to right, as you can see here. Oh, gotta go down. This one goes down from left to right, so it goes in a downwards direction from left to right. That's because it has a negative slope, and a line that has a negative slope is going to go in a downwards direction. Again, things you'll definitely explore more about later. All right, let's take a look at number 4. This is a little bit harder because x and y are on the same side, so there's going to be a little bit more work involved. I'm going to start with x equals -1. So I did -5 times -1, which got me 5. So I have 5 plus y equals -2. And then I subtract 5 from both sides to get y equals -7. So I basically had to solve a one-step equation there. So -1, -7 will be on that line. I then plugged in 0. -5 times 0 is 0. And if I have 0 plus y equals -2, then y has to be -2. So again, it's really important to use 0 because that work is usually a little easier. Let's plug in 1. So -5 times 1 is -5. -5 plus y equals -2. Add 5 to both sides. We get y equals 3. And then finally replace x with 2. So we've got -5 times 2 to get us -10. -10 plus y equals -2. We'll add 10 to both sides to get y equals 8. So 2, 8 will be on that line. Let's go ahead and graph these points, make sure they form a line. So we have -1, -7, which is going to be right down here. We have 0, -2, which is going to be right here. We have 1, 3, which is going to be right here, and then 2, 8. It's going to be right there. So those are a little bit more stretched out. Now you might be wondering, wait a minute, the number in front of x this time is a negative, but this line goes up from left to right. And that's because this one is not in what we call slope-intercept form, which means that it's not in the form like y equals mx plus b, so you don't have y equals something times x. Now, if you did solve this for y by adding 5x to both sides, you'd get y equals 5x plus negative 2. And that would give you a slope of 5. You can see that this line is pretty steep, so it makes sense that it would have a slope somewhere around 5 or a larger value or larger number. Okay, continuing with number 5, just kind of looking at some of these more challenging questions here. We want to find 4 solutions of negative 2x plus 3y equals negative 6. So I stuck with those same values. We're going to start with negative 1. We do get some decimals here, so you can always choose different values if you want. So replace x with negative 1. Negative 2 times negative 1 is 2. So we have 2 plus 3y equals negative 6. We now have to solve that two-step equation. So we subtract 2 from both sides to get 3y equals negative 8. Divide both sides by 3, we get negative 2.6 repeating. We'll show you how to graph that. We can still graph decimals on here. You'll notice these points end up being pretty close together. All right, we've got 0. Replace x with 0. Negative 2 times 0 is 0. That leaves us with 3y equals negative 6. Divide both sides by 3, we get y equals negative 2, so that ordered pair is 0, negative 2. Replace x with 1. So you have negative 2 times 1, which is negative 2. Add 2 to both sides to get 3y equals negative 4. Divide both sides by 3 to get y equals negative 1.3 repeating. And then finally, if we replace x with 2, negative 2 times 2 is negative 4. Add 4 to both sides to get 3y equals negative 2. Divide both sides by 3, we get y equals negative 0.6 repeating. So we're going to graph these. Again, they're going to be pretty close together. That's why you may want to choose different values for x, but you can choose whatever you want. So we have negative 1 comma negative 2.6 repeating, which is going to be like down here-ish. The next one is 0, negative 2, which is going to be right here. Oops, I put negative 1.6 repeating. Negative 2.6 repeating. Let me get the right spot there. There we go. That's much better. We have 1, negative 1.3 repeating. That's going to be right around here. And then 2, negative 0.6 repeating, which is going to be right around here. So they do form a line. Again, as I said, all those points are going to be really close together just because of what we chose, but you can choose any values for x that you want. So if you spread those out a little bit, the points would be a little bit more spread out. All right, let's take a look at number 6. So for question number 6, for this problem, our equation is y equals 1/2 x minus 3, and that graph is actually right on, I guess I shouldn't say number 6, sorry, this is actually number 11 because 6 was one of our graphs. So we're skipping down to number 11 here on the back of that one page, and what we're going to do is replace values for x to solve for y. Now I suggest you choose numbers that are multiples of 2 because you're multiplying by 1/2. So I chose all positives actually for this one. I chose 0, 2, 4, and 6. Let me go ahead and slide this out of the way. There we go. So if I replace x with 0, I'm going to have 1/2 times 0 minus 3, which gets a 0 minus 3, or negative 3. If I replace x with 2, 1/2 of 2 is 1, and 1 minus 3 is negative 2. If I replace x with 4, I've got 1/2 times 4, which is 2. 2 minus 3 is negative 1. And then we do 1/2 times 6 to get 3. Let me slide this down. Sorry about that. 1/2 times 6 to get 3. 3 minus 3 gets us 0. So our ordered pairs are going to be 0, negative 3, 2, negative 2, 4, negative 1, and 6, comma 0. Let's go ahead and graph those. 0, negative 3 right here. Excuse me. 2, negative 2 is going to be right here. 4, negative 1 right here. And 6, comma 0 right here. We'll go ahead and connect these with a line. Good. And it'll look like this. Again, you want to choose values for x that make sense for the problem. If negative 1, 0, 1, and 2 don't make sense, choose numbers like 0, 2, 4, 6. Choose multiples of 3. whatever's going to work the best for you to get some decent ordered pairs to graph. Now keep in mind, something that we should actually know is that you only need a minimum of 2 points to form a line. I like to have 3 or 4 just to really confirm that I'm on the right track, that I've got the right ordered pairs as well. So at this point, you should have all the way up through question number 11 done, because remember, we did the graphs as we were doing our tables as well, the ones that matched up. So our next question here is number 12, and in question number 12, I didn't cover any of this stuff up, so we'll take a look at all of our work step by step here. This problem has us making a table and graphing 4x minus y equals -4. Now for this one, I did choose 0 and then all positive numbers. So I started with 0, and I took 4 times 0 to get 0, and I did rewrite minus y as plus a -1y. So I have -1y equals -4. Divide both sides by -1, we get y equals 4. So the point 0, 4 will be on this line. I then replaced x with 1. 4 times 1 is 4. I then solved that two-step equation by subtracting 4 from both sides to get -1y equals -8. Divide both sides by -1 to get +8. Replace x with 2, so we've got 4 times 2, which is 8. Subtract 8 from both sides to get -1y equals -12. Divide both sides by -1 to get y equals +12. And we can see this pattern that our y's are increasing by 4s. Finally, I'll replace x with 3. 4 times 3 is 12. Subtract 12 from both sides to get -1y equals -16. Divide both sides by -1 to get +16. So we've got our 4 points here. Now, if you notice, this is a 10 by 10 coordinate plane that we have here. So we're actually only going to be able to fit these first 2 points on this graph unless we choose to count by something other than 1s. But we only need 2 points to make a line anyway. So 0, 4 is going to be right here. 1, 8 is going to be right here. If we were to graph 2, 12, that would be off of this line somewhere around here. So we could continue that if we wanted to. But I'll go ahead and connect these and make a line. And it's going to be a line that looks somewhat like this. All right, so we made our table, we graphed that line. All right, let's go ahead and take a look at number 13, which is a word problem related to graphing and making tables for linear equations. Apps cost $3 to download onto a cell phone. Ringtones cost $1. You used to actually have to purchase ringtones. Find 4 solutions of 3x plus y equals 20, which is the linear equation that represents this situation. In terms of the number of apps x and ringtones y, Darcy can buy with $20. Explain what each solution means. So, first thing I did was I chose x, or I let x be 0. And 3 times 0 is 0. You get 0 plus y is 20, so y is 20. And what this means is that when Darcy buys 0 apps, because keep in mind, x represents the number of apps, we can even type that in here, and y represents the number of ringtones. So 0 apps, 20 ringtones. So when Darcy buys 0 apps, she can purchase 20 ringtones. I then replaced x with 1, so I did 3 times 1 to get 3. I subtracted 3 from both sides to get y equals 17. So what this means is that when Darcy buys 1 app, she can purchase 17 ringtones. I replaced x with 2. 3 times 2 is 6, so we'll subtract 6 from both sides to get y equals 14. This means that when Darcy buys 2 apps, she can purchase 14 ringtones. And then my last one was 3. So I do 3 times 3 to get 9, subtract 9 from both sides to get y equals 11. What this means is that when Darcy buys 3 apps, she can purchase 11 ringtones. Now, something for us to keep in mind here is that we need to be smart about what numbers we use. We can't choose negative values for x. Also, if we get too large of a number of apps, for example, if we get into, let's say, 7 apps, since they cost $3 a piece, we'll already be over that $21. So we are a little bit limited for what values of x and y we can use or choose as we're solving this linear equation and creating our table. So that's just something for us to keep in mind. Let's go ahead and take a look at number 14. Kirsten is making shortbread cookies using her grandmother from Germany's recipe and needs to convert grams to ounces. The equation y equals 0.04x describes the approximate number of ounces Y in X grams. So we need to find 3 ordered pairs that satisfy this equation. I actually used X equals 100. So since I saw this graph that we had here, I started with numbers like 100 because obviously if you're just plugging in 1, that's going to be pretty hard to graph on this. So I let X equal 100 and I did Y equals 0.04 times 100, which is 4. So that ordered pair will be 100 comma 4, and I can actually graph this. That would be right here. I then chose 150 as my next one, so I did 0.04 times 150, which got me 6. So 150 comma 6 would also be on this graph. And then the last ordered pair I chose was, or the last value of X I chose was, oops, I just realized I changed it to Y by accident, sorry, X. So I let X be 200, and I did Y equals 0.04 times 200, which gets us Y equals 8. So 200 comma 8 would be an ordered pair. I can go ahead and connect these. For this, it's really just going to be like a one-sided line just because it can't go into the negatives, which we'll talk about here in part C. So part C says, do negative values of X make sense in this case? Explain. No, you cannot have a negative number of grams of an ingredient. So if we're talking about measurements in this case, we can't have negative values. Kind of like on the apps and ringtones question before, we couldn't choose a negative number of apps. We also couldn't have a negative number of ringtones. So we have to be careful which values we choose there. That's always something for us to keep in mind when we're talking about a real life situation. Now, our last set of questions are going to ask us whether a table or whether or not a graph is going to be linear, and we'll talk a little bit about that. So don't forget, linear equations look like lines. X and Y need to be in separate terms, and we can't have any exponents besides 1. If we have an exponent besides 1, like in these situations here, or if X is, let's say, in the denominator of a fraction, we're going to get something that isn't linear, meaning it's going to look somewhat like a curve. This is what we call a parabola here. This is a cubic function that we have going on here, so it looks like a line with a little curve in the middle. And then something like this is going to be using negative exponents, so 3x to the negative first power. And you'll talk about those kinds of functions in the future. So for numbers 14 and 15, we want to determine whether each of the following relations or equations are linear. And for these, since we're given a set of points, we should probably graph them and see if they form a line. So negative 1 comma 4 is going to be right here. 0 comma 5 is going to be right here. 1 comma 6 is right here. And 2 comma 7 is right here. It looks like they form a line, so we can say that this would be linear. So let's go ahead and explain that. Yes, it is linear since the points form a line. And we'll go ahead and move that over. Let's take a look at number 15. So for number 15, we have negative 1, negative 5. I have to move this down. So negative 1, negative 5 will be 1, 2, 3, 4, 5 right here. We have 0, negative 2. Just going to be right here. 1 comma 1 and 2 comma 5, which is going to be right here. So looking at these, it looks like they form a line. One thing that you can do is count how many units up and to the right we go to get to the next point. So 1, 2, 3 units up, 1 to the right, 3 units up, 1 to the right, 1, 2, 3 units, actually it's 4 units up, 1 to the right. And we can kind of see that even though our x's are counting by ones each time, our y's are increasing by 3, and then by 3, and then by 4. This last point that we have here, which I'll highlight, is not actually going to be in that line. It's just slightly off. So no, it is not linear. We could even say the last point should be 2 comma 4. If it were 2 comma 4, then this would be a situation where it would be linear. You could say that last point's not going to be on the line. It's very close though. In fact, when you're first looking at it, because we're graphing on such a small coordinate plane, it actually almost looks like it's going to be on the line. If I connect these perfectly though, it's just slightly going to be off that line. Let me go to make that a little bit better. We can kind of see it just slightly off the line, but barely, which again is because it should be 1 unit down from where it is to be linear. All right, let's take a look at number 16 through 19. So number 16, x and y are in separate terms. You don't have any exponent besides 1. That's definitely going to be linear. For number 17, you have an exponent besides 1. You have an exponent of 2. So I said, no, it's not linear. The exponent on x is not 1. Number 18, we don't have a y in this equation, but that's okay. This is actually going to be a vertical line, which we talked about in the very first page of the notes. And then for number 19, x and y are separate terms. The exponents on the variables are 1, so it's going to be linear. So keep in mind, we can look at the equation. We can also have a table of values that we can graph. One thing, again, you just want to double check is that pattern. So in number 14, as the x's were increasing by 1s, the y's were also increasing by 1s. It doesn't have to be that they increase by the same thing, but it has to be a consistent ratio. So in number 15, the x's were increasing by 1s. The y's were increasing by 3s, but then it changed on that last point, which made it not completely linear. So we've talked about a lot of things in this lesson. We've talked a little bit about graphing lines by making a table. Some lines were pretty easy to graph because we had y equals some number times x. We also had some where x and y were on the same side, so those were a little bit more challenging. But one way to graph a line is always by making a table. Find some ordered pairs and connect them. That can help us graph that line. I do suggest a minimum of 3 ordered pairs or 3 points. 2 is sufficient, but it's definitely good to have 3 or 4 just to make sure they also fall in line as well. All right, thanks for listening.